Does the silence of space hide a secret? In such a vast universe, with billions of stars and planets, why haven't we heard a single voice or seen any signs of another intelligent civilization? Could it be that we're looking in the wrong places, using the wrong tools, or is there something much greater preventing us from finding answers? The Fermi Paradox makes us wonder, what if intelligent life is incredibly rare? Or worse, what if advanced civilizations inevitably destroy themselves before they can explore the cosmos? Perhaps the silence of space is merely a misperception. We're searching for radio signals, but what if extraterrestrials communicate in ways we can't even imagine? Or could they have chosen not to reveal themselves, like someone observing a zoo without interfering? The mystery endures, but each technological advance brings us closer to answering the question that refuses to go away. Are we truly alone? Or have we yet to learn how to hear what the universe is? Trying to tell us what is the Fermi Paradox? Imagine looking up at the night sky and seeing a sea of stars shining in the darkness, each one with the possibility of planets orbiting around it. With billions upon billions of stars in our galaxy, it seems logical to think that somewhere out there, intelligent life must exist beyond Earth, right? This very question was posed by the scientist Enrico Fermi in 1950. During a casual lunch with colleagues, he suddenly asked, "Where is everybody?" This simple yet profound question gave rise to the famous Fermi Paradox. The paradox is like arriving at a massive party you knew would be packed with people, only to find the venue completely empty. You ask yourself, did I arrive too late? Or did the party never happen? In the case of the universe, the party represents the existence of advanced civilizations. The question Fermi raised is both simple and perplexing. If the universe is so vast and teeming with stars, and if life can naturally arise, why haven't we seen clear signs of other civilizations? Where are the spaceships, radio signals, or any evidence that we're not alone? Some suggest we might not know how to search properly, or that we're using the wrong tools. Others believe intelligent civilizations may have disappeared before we had the chance to find them. Is the answer hidden in the silence of space, or is there something we're overlooking? The Fermi Paradox continues to provoke thought, ignite imagination, and inspire us to look even more closely at the vast and mysterious cosmos around us. The Drake equation and the probabilities of life. To address the big question, how many intelligent civilizations might exist in the universe? Scientist Frank Drake devised a formula in 1961 that became an essential tool in the search for extraterrestrial life. The Drake equation isn't exactly a recipe with ready-made answers, but rather a way to organize what we know and don't know about the conditions that could lead to the emergence of intelligent civilizations. Imagine wanting to bake a cake, but not knowing the exact quantities of the ingredients. The equation helps identify the ingredients needed for life to arise, the rate of star formation in the galaxy, the percentage of stars with planets, the number of planets that might have suitable conditions for life, like liquid water, the probability of life emerging, the chance of it evolving into intelligence, and the duration a civilization remains detectable. The more stars and planets available, the greater the chance of finding life. However, there's a problem. We don't know many of these numbers with precision. For instance, how many planets truly have the right conditions? And even if life arises, does it evolve into intelligent beings? Another intriguing question is, what if alien life forms are so different from us that we wouldn't even recognize them? Maybe they're not sending radio signals, but using technologies beyond our imagination. The Drake equation doesn't provide definitive answers, but it reminds us of how vast and full of possibilities the universe is. Each discovery of exoplanets and biosignatures helps fill in the gaps. Could the cake of life be baking in other corners of the galaxy? Or are the ingredients for intelligent life even rarer than we imagine? The Great Filter. Imagine the evolution of life as a video game with multiple challenging levels, each representing an obstacle that must be overcome for an intelligent civilization to emerge and thrive. The first level is the most basic. Simple molecules must organize into something capable of reproducing. The beginning of life, which may have occurred on Earth billions of years ago. But that's just the start. After this, life must face other levels, evolving into complex organisms, developing intelligence, and eventually creating a civilization capable of exploring the cosmos. The concept of the Great Filter suggests that there might be one particularly difficult or impossible level that most forms of life fail to surpass. Perhaps the filter is near the beginning, making complex life incredibly rare. Or maybe it's at the end. Advanced civilizations might self-destruct through wars, climate change, or resource depletion before they can explore space. This could explain why we haven't found signs of other civilizations. Now consider this. Have we already passed the Great Filter? Perhaps the emergence of life on Earth was a statistical miracle, and we've overcome the hardest challenge. Or is the filter still ahead, waiting to test us? It could be something like learning to live sustainably or avoiding dangerous technologies. The question remains, will humanity pass the test, or will we become just another silent chapter in the story of the cosmos? The Great Filter, reflecting on the fragility and preciousness of life. The idea of the Great Filter makes us reflect on how fragile and precious life is and how much effort we need to ensure our civilization keeps advancing. After all, the next level of this cosmic game could be our chance to explore and understand the universe, or the last phase we might never surpass. Cosmic timescales and distances. Did you know that the starlight we see today may have started its journey millions or even billions of years ago? Space is so vast that even at the speed of light, the fastest in the universe, it takes years to reach nearby places like neighboring stars. Now imagine trying to communicate with a civilization in another galaxy. If they sent a signal, it might take thousands or even millions of years to reach us, and by the time we receive it, whoever sent it might no longer exist. It's like writing a letter to someone who moved away centuries ago. Additionally, consider the lifespan of a civilization. Earth is 4.5 billion years old, but humanity has only been using technology for about 200 years. What's that compared to the age of the universe? Civilizations could rise, develop, and disappear in the blink of an eye on cosmic scales. Are we looking for neighbors who are long gone or not yet born? These time and distance scales are a powerful reminder of the universe's immense mystery. The role of detection technologies. Ever tried to listen to a conversation during a storm? It's challenging, and that's what it feels like when we use telescopes and satellites to listen to the universe. They act as giant ears, trying to pick up radio signals, light, or any other forms of communication coming from distant stars. Projects like SETI, Search for Extraterrestrial Intelligence, are dedicated to this, analyzing the silence of space for messages that might indicate intelligent life. But there's an intriguing problem. What if ETs use completely different technologies? Imagine a modern smartphone trying to communicate with an old radio. It wouldn't make sense. They might use frequencies or methods of communication we don't yet understand or detect. Despite these challenges, science persists. We're developing increasingly powerful telescopes and using advanced algorithms to analyze signals with greater precision. Who knows what these cosmic ears might catch in the future? Maybe we're about to hear the first word of a conversation that started long ago. Hypotheses on non-detection. Why haven't we found anyone out there yet? This question has inspired many intriguing theories. One is the galactic zoo hypothesis. Perhaps ETs are observing us from a distance, just as we observe animals in wildlife reserves. They might be waiting for us to reach a certain level of development before making contact, or they may see us as a young and unpredictable species. A darker hypothesis suggests that most advanced civilizations self-destruct before they can explore the universe. Wars, climate change, or irresponsible use of technology could end civilizations before they become detectable. Others believe that intelligent life is incredibly rare, like winning the cosmic lottery, a combination of factors so unique that it's unlikely to repeat. And what if we're looking in the wrong places or in the wrong ways? Perhaps the signals are all around us, but we don't know how to interpret them. Are we an exception or just another piece of the cosmic puzzle? The answer might be closer than we think, or as distant as the stars we admire. The future of research and perspectives. With increasingly advanced technologies, we're entering an exciting era in the search for extraterrestrial life. Telescopes like James Webb are revolutionizing our ability to explore the cosmos, allowing us to sniff the atmospheres of distant planets for biosignatures. Gases like oxygen, methane, and carbon dioxide that might indicate the presence of life. Additionally, scientists are focusing on finding techno-signatures, such as signs of artificial light, radio emissions, or even industrial pollution on exoplanets. Clues that could reveal technological civilizations. It's like exploring an unknown forest, looking for subtle footprints that indicate something alive. Every new discovery, no matter how small, brings us closer to answering the age-old question, are we alone? Future projects, like missions to study potentially habitable moons in our own solar system, such as Europa and Titan, also offer incredible hope. The most exciting part is that science doesn't stop. With global collaborations and advances in artificial intelligence, we're pushing the limits of detection and understanding. The answer might be just around the corner, or on the next planet we investigate. In the meantime, we remain curious and determined to uncover the universe's secrets. Subscribe to the channel and turn on notifications so you don't miss upcoming episodes about the mysteries of the universe. Leave a like and share with anyone else who wonders, are we really alone? Comment below, what's your favorite theory about the silence of space? Let's talk.